I was going to respond to your arguments, but a commenter here, and yes, it appears to be a soccer account, but the reason people set up soccer accounts is because you block everybody, because you can't deal with the arguments. So before you delete this one, I will immortalise it by reading the arguments out. So you apparently said it's a logical conclusion of the theory that the same amount of fuel gives more energy to lighter objects. I don't know if you actually said fuel. Maybe you said energy, but anyway. So the response here is, no, it's not. You started with the assumption that the same amount of fuel gives the same amount of momentum to any mass. But this is not true in the mainstream theory or in reality. That's the key point there, reality. You have seen the same spring compression give different amounts of momentum to different masses. You have seen equal momenta compress a spring different amounts. Energy is energy, momentum is not. So that's the bit you don't seem to understand. Because you're saying if you compress a spring and put different masses in front of it, you can get different amounts of energy. No, you can't. You can get different momentums, you will get the same energy, whatever mass you put in front of it. Argument 2. Ballistic pendulums don't conserve kinetic energy. Yes, because they get deformed. You can't make work to deform something and keep your kinetic energy. Ballistic pendulums are not evidence against the mainstream theory because they behave exactly like the theory predicts. Again, the ballistic pendulum is to measure the momentum. That's what it's designed to do. Mythbusters, crash cars, and there was no evidence of kinetic energy. This one's been told to you many times. To know the energy spent as work, you would need to know the force that was used, and you don't. But if we assume that the force required to keep crushing the car increases with further crushing or further distance, like it does when you compress a spring, twice the speed and twice the crushing is the result you would expect according to mainstream theory. And yes, this is true. So again, you use the Mythbusters as an example for your bullshit theory, but it actually is a perfect prediction of kinetic energy. Argument 3. In Bruce Yearney's experiment, the higher kinetic energy didn't win. That's another prediction of mainstream theory because of equal and opposite momenta. So it doesn't really work as an argument against it. Also, the neat thing is, in this experiment, you can see how the lighter block is accelerated by a larger portion of the rubber band. If the masses are 1 and 2, and the one mass is pulled by twice the amount of rubber band, so it gains twice the energy. A nice piece of evidence, which I would agree, yes, because it shows that the two masses, so you've got a 1 and 2 mass, and they end up with equal momenta. But the one mass is pulled by more of the elastic band. More energy has to go into it to equal the momentum, which again shows that energy is not momentum and momentum is not energy. So this is another one apparently you said. Kinetic energy can't do any work. It can't win in a crash. You don't have a definition for work. Your definition used to be W equals force times time, but that got you into trouble, so now you choose to be vague. Yes, which you do. You know, you don't pin yourself down to a proper argument, you're just a bit wishy-washy, so you can't get pinned down or challenged on anything. Argument 4, it's completely anti-Newtonian. No, it's perfectly Newtonian. Force generates motion, F equals ma. But since you brought up Newton again, when are you going to read about the pendulum experiments? Are you not interested? Yes, you did seem to mention that you were reading Newton and you were going to make a video putting everything, right that he said wrong, apparently. And fully enough, you haven't bothered with that, have you? So there you go. There's all your arguments debunked. None of the examples you use actually are an argument for your bullshit. They all are in line with mainstream theory, and that's it, really. I mean, I don't... you've seen all the evidence, and then in this video today, you said something about, when did springs only have to compress 0.4 or more? Not 0.4, 1.4. There's a big difference. If you times it by 0.4, it's fucking less compression. It's 1.4. And yes, if it's twice the energy, it will compress 1.4 times more. It's not a new thing. Try it. That's the thing. You don't try anything. I've shown it fucking loads of times. Everybody else has. It's the same with, like, 25 times the energy can do 25 times the work. No, not on a spring. It'd be 5 times. 5 times the compression would equal 25 times the energy. But the thing is, you're asking to see experiments. We're showing them. And you just don't understand what you're seeing anyway. So is there really any point in asking for experiments that you're going to look at and go, well, that doesn't make sense to me, I don't understand, so therefore it's wrong. That's all we get. It's like arguing with a fucking toddler. You've seen the evidence. Okay, you don't understand it because you don't pay attention. You don't watch it. You just blast through it just so you can insult people. That's it. You don't pay any attention. You don't try and learn. You just say, I don't understand it. So, me, genius, so therefore, if I don't understand it, it must be wrong. It's ridiculous, but you're wrong on so many, well, everything really. I'd say so many, but no, I don't think you ever said anything right. So, there we go. So, I was going to actually do it myself, but this comment, who is it? Pet Peanut. So, sock accounts. But like I say, the reason people do sock accounts is because you block everybody. And people do make arguments, valid arguments. You're the one that ignores them. You're the one that evades them. You're the one that strawmans them because you simply don't understand the argument being presented. You don't understand the evidence being presented to you. You've been shown and proved wrong, evidentially, time and time again. The evidence that you can't debunk, you just ignore. And yes, some of the experiments aren't perfect and you pick on every possible flaw, but ultimately they still show you to be wrong.